As you see is what you see is in a pressure gauge of burden tested diagram. You see your ring case, burden spring tube, and tip of the pointer sector and sector adjacent arm, a junction. Sorry, a sector a junction arm connection link, and a sector spindle and pipe connection, hollow socket and pinion, hairspring, and glass 15 dial. Right here, you're seeing a spring loaded, and it has the gauge screw, the fluid, and that is your pressure gauge burden tube mechanism. Moving the lever in the gear system. Moving the lever in the gear system, rotating the pointer. There are four common types of the board and tube gauge: the simplex, vacuum, compound, duplex. The simple gauge is used in measuring pressure, steam and air, water, oil, similar fluid, gases. The vacuum pressure, measuring the absence of atmospheric pressure, indicates the vacuum in inches. And the mercury compound gauges measure vacuum in the to the left of the 0 point of the pressure, to the right of the 0. The duplex differential pressure gauge consists of two independent mechanisms within the same case that has the two inputs. Potential operated and independential indicated the pressure drops between the inner sides of the outer sides, and the strainer filters the bellow gauges. In general, used to measure pressure gauge of the bellows 15 psi Gs. The measure increases into the sensing lines of the bellow gauges. The bellow expands to operate the system of the gears and levers that are connected to the pointer. The pressure of the bellow gauge decreases as the bellows concentrates and returns the pointer toward the 0 point. Diaphragm gauges are very sensitive. Given reliability indicates small differences in pressure of the gauges. Mechanism consists of tough, pliable neoprene rubber membrane connected to the metal spring and is attached to the simple linkage system of the gauge pointer. The one side of the diaphragm exposed to the pressure being measured while the other side is exposed to the atmosphere. The pressure is applied to the diaphragm, and it moves the pointer into the increasing reading, and the dialing the pressure is lowered to the diaphragm, moves the pointer back towards the 0 point. 510.2, the pressure gauge maintenance. The gauges are delicate and sensitive measurative devices and require the exact calibration. Unlike calibration will be done, the gauge is normally location in the regular interval of the the gauge should be properly isolated, removed into the meteorology and calibration lab, and to ensure the continued accuracy. Gauges are subject to damage, excessive pressure and vibration, corrosive environmental metal fatigue, abuse, and gauges suspected such as damage should be removed from servicing, tested as soon as possible. Cracked or abraded dial from the gauges should be noted for replacement as the glass forms a seal against the environment. Sometimes inoperative and accurate gauges are caused by the damage to the tubing connecting the gauges as its pressure sources, or to petcock the valve and isolating the tube of the piping. The liquid pressure of the gauge and leaks are indicated in the fine midst of the droplet. The use of tubing and gauging since the fluid itself it drives and gauge sensitive elements. The pressurized gas handling system such as air applying to the soapy water solution if the leak sources yields a bubble. If a leak is present in small leaks of the vacuum tube is identified, and covering the suspected leak of a non-porous plastic film or Teflon tape of the gauge is observed. If the leakage gauge pressure will change significantly when the tape is applied, the attachment of the tube to the gauge is common as source of the leakage of the wrapping Teflon tape around the threads in connection often seals the leakage. 510.3, the meters. Meters are installed at fuel receiving delivery lines, measuring the bulk fuel quantity flowing through the line. And since the fuel delivery quantity is normalized in 60 degrees Fahrenheit for accuracy, some meters are compensating the fuel meters differences. Positive displacement meters are installed in the use of line service, aircraft, ground vehicles, or small boats. And when turbine meters are acceptable, long duration, steady state transfers. To 510.3.1, meter description. Positive displacement meters measure flows in analog conversion of the motion transferred to rotating the vane through the calibrated set of the gears driving the counter registry. The turbine meters that operate in a similar fashion except for the substituted axially aligned rotor from the vane. The clearance of the rotor housing allows some slippage for the type of the meter is less than accurate. To maintain accuracy, protection meter prevent movement, flowing control, and device and strainers installed in the upstreams of the meter as a means of adjustment of the card key to the activated electronic tap to the meter, allowing automatic accounting of the fuel deliveries and identified to the users. Some meters provided by the preset fuel delivery total that may be used to slow the fuel to determine the rate of the void a hydraulic shock of the present preset fuel total is approached. 510.3.2, meter maintenance. Although the meter is mechanically simply associated with electronic controls and adjustment of the causes the meter to require assignment for the most maintenance actions beyond the calibration. Calibration can be accomplished by attaching portable voltmetric prover, a calibrated master meter, or a pipeline prover adjusting for the meter can coincide with the acceptable standard preferred to the technical manual for a specified frequency and procedures, and strainer inspection otherwise uncovered in the strainer installed upstream should be inspected regularly, scheduled basis in accordance with its technical manual. Section 5.5 of this manual provided the additional guidance. 5.11 hoses.